everyone, welcome to today's lesson. Today we are on lesson 1-4, and in this lesson what you're going to learn is how to perform a decomposition of functions. Our language objective is to explain the steps we need to take when performing a decomposition of functions. So let's take a look at our do now. Let's take a look at today's do now. Today's do now, we are answering the following. What they gave us are two functions, the f function and our g function, and we are asked to find a composition. So I'm going to make you guys pause the video, try part A and B, and let's see if we have the same answer at the end. Okay, so here are our two answers. For part A, I got a negative x squared plus x plus 4. Again, we have a composition, g composed of f of x, which means f of x is what I'm starting with. My input is x, so nothing changes to the function. I get the output of x squared plus x. I input that output into my g function and end up at that answer. For part B, we're doing the same thing, only that this time we're starting with the g function. Our input is x plus 1. I input that into my function. I have to be careful here because I'm subtracting the input, so that's why I included extra parentheses here. And I did my distribution. I got negative x plus 3 as my output. That output is my new input for my f function, leaving me with a final composition answer of x squared minus 7x plus 12. So now that we did our quick do now, let's look at what we're doing. So today, what we are looking to do is how do we perform a decomposition of functions. In math, we always have a way to go forward and we have a way to go backwards. So we did a composition. That was what we did in our do now. That was what we did in our last lesson. Today, what we're going to be working with is the backwards portion of this. So a decomposition of functions. Recall, when we do a composition of functions, we are given multiple functions and are asked to take one function's output and use that into another function. So a decomposition, what we're going to end up doing is when we are asked to do a decomposition of functions, we will be given the output and are going to be asked to be finding the original functions that led us to that output. So we're working backwards, as I said. Helpful tip, you will need to identify the inside function and the outside function. So let's look at what this is all about. In example 1, what we are doing is we're going to be performing a decomposition of functions. So we have if f of x is equal to 10 to the x power and h of x is equal to 10 to the x squared minus 17 power, find a function g of x such that h of x is equal to the composition of f composed of g of x. So let's just think about this. We have a function h of x. That function is the composition piece. And that composition piece comes from us doing f composed of g of x. So if we were doing this the way we learned composition, what we would do is start with the innermost function, which is g of x. And when I do that g of x piece, some output is going to be given to us. This is our goal. We were trying to find this output. So I input something, some output comes out. That output is what we're going to be using into the second function. So we have f composed of the output, but we don't know what the output is. But we do know where this led us. It leads us to get a 10 raised to the x squared minus 17 power. That's the composition answer. So what I need to figure out is how did I end up here? My f function. So now I'm going to look at that f function more closely because that's what I'm going to start with. I'm starting backwards. I'm starting here. And I'm going to ask myself, okay, the f function is 10 raised to the x power, 10 raised to the input. But I need to figure out that input. Again, that's my output for the g function. So let's think. What could the input be? The input could have been x squared minus 17. Why? Because my f of x function is 10 raised to the input. And if I know that the input is x squared minus 17, that must have been the original output for g of x, or my original g of x function, leading to my answer, g of x is equal to x squared minus 17. Now, this is the way I thought of it. Is this the only way? No. You could figure out different inputs. As long as the composition piece comes out true, then your answer is correct. How do I know this works? Well, if g of x is equal to x squared minus 17, then I would take that function and input into my f of x function, or f of the input function, leading me to that 10 raised to the x squared minus 17, which is also known as my h of x answer, my composition answer. Okay, so this is me checking my work right here. So I won't do that for all of them, but this is the logic of how you're working with these types of problems. So let's look at number 2. The same kind of process, right? I'm going to be given two functions. They gave me my f of a function to be the square root of a. They gave me my h of a function to be the square root of a squared plus 4. Find the function g of a such that h of a is equal to that composition. So here is my composition piece. H of a. Where is h of a? Right here. So this is the last thing that occurred. If I'm following the flow of the composition, I start off with g of a. Some output happens. Whatever that output was is my input for my f function, giving me my answer of h of a, which is square root of a squared plus 4. That's my answer. That's my composition answer. Okay, so let's think about this. F is the square root of a, the square root of the input. Now, what is my input? What I'm looking at is what's under the radical here, a squared plus 4. Which is leading me to believe that that must have been my original g of a. Doesn't it make sense? If g of a was equal to that function's output, which is a squared plus 4, then that means that that would be my new input for f of a function. And I'm able to input that a squared plus 4 into my function itself, leading me to my answer of h of a. So function's original g of a must have been a squared plus 4. Okay, again, this is the way I'm thinking of it. Is this the only way? No, there could be various answers for some of these. All right, let's try 2 more and let's see if we kind of get the hang. So for number 3, find functions f and g such that the composition is equal to that cube root of 2x plus 3. So here's my composition, my answer, right? So let's think backwards. Somehow I start off with my g function. Something happens or some function is given to us and we have an output. That output is our new input for our f function. And when I do that, I end up at my answer, the cube root 2x plus 3. So what could these functions have been? So again, various answers. This is what I'm thinking about. If my f of x function is the cube root, if this is my function, then for me to change it to this cube root of 2x plus 3, all I'm really doing is inputting 2x plus 3. Okay, so this is the function that I'm going to start with. I'm going to assume that f of x was the cube root of x. And if it was, that means that my input must have been 2x plus 3, which means that g of x should be that 2x plus 3. Now, is that the only case? No, I'm going to do a different case here. Let's say that my f of x Let's say that my f of x is the cube root of x plus 3. Now, if that is the case, then what must be inside the parentheses to get that cube root of 2x plus 3? The only thing that will make sense is if my input instead of an x was a 2x. Means that g of x must be equal to 2x. So here is two other functions that we could have started with. For these questions, sometimes there's multiple ways of looking at it. As long as that original function's output makes sense to the flow of the composition, you're correct. They aren't specifying that one function must be this. If they do, then there's a little bit more limit to your answers. Let's try one more. Your h of x function is 1 over x plus 1, where your h of x is the composition piece. Decompose h of x as two functions. So we have been given our composition. We do something and this is what happens. So in this case, I start off with g of x. We get some output. That output is what we input into the f function, leading us to our h of x, which is 1 over x plus 1. Let's say that f of x is 1 over x. Let's just assume that. If h of x is 1 over x, what must my input have been for me to get this 1 over x plus 1? Only thing that I changed is that denominator, which means that my input should be x plus 1, which means that's my original output for my g of x function. So those would be my two possible answers. So for this one, you could think of it in different ways. I won't give a different situation. I'll see if maybe you could come up with different ways to make your composition hold true. So as far as this goes, make sure that the flow of the composition works. You always do your innermost function. You work your way outwards. That's pretty much what I'm doing here, but I'm trying to fill in the puzzle. Like, what could this have been? There is no one answer fits all for all of them. There's some questions in which there's multiple ways to look at it. If the flow of the composition is true, there is no way that anyone could tell you you're wrong. So I do have to pay attention to the flow of your function. So keep learning, keep growing, and I will see you in our next video.